I'm especially passionate about music, art, sports, and tackling gender injustice and poverty. At Mahatma, I'm currently building a chatbot for people in rural India to help discover their passions. You interact with our chatbot and share your hobbies, your favorite subjects, your job preferences in your local language, and the chatbot helps you with customized life path information related to your chosen career. My goal is to use technology to help people everywhere live more meaningful lives, which is why I absolutely love the research Professor Bernstein has done at Stanford.
Hey everyone, I am Arav Mohan. I'm a student at the Canadian International School, Bangalore. I love reading, coding, working with animals, and sports. I believe that one core method of implementing long-term social change is through education. And I'm interested in tackling issues such as privilege and poverty. At Mahatma, I'm working on a project which recruits students to work with grassroots NGOs and support them by creating high-impact tech solutions. They would help with projects like managing Instagram pages and making commercial APIs. I especially love Professor Bernstein's work with its focus on building teams to achieve progress. I really do believe that to move forward as a species, we really do need to work together.
Moving on to Professor Bernstein. Professor Bernstein is among the world's leading authorities in the field of human-computer interaction. His research focuses on the design of social computing and crowdsourcing systems. Put simply, his lifelong goal is to build computing systems that encourage us to come together to solve our biggest problems.
What if the smartest minds of our generation could be brought together with a single click? What would you do with that? Professor Bernstein's lab at Stanford researchers have designed technology intertwined in crowdsourcing. It shows how computer science can enable the crowdsourced creation of short animated movies, mobile apps, Kickstarter-backed card games, and much, much more.
Professor Bernstein's work has received several Best Paper awards at ACM Chi and has appeared in venues such as the New York Times, Slate, CNN, and The Atlantic. He has been recognized with an NSF Career Award at the Alfred P. Sloan Fellowship. Professor Bernstein holds a bachelor's degree in symbolic systems from Stanford University, as well as a master's degree and PhD in computer science from MIT. Moving on to the questions. I am 15 years old. Could you describe to us what you were doing when you were 15 and how did you get where you are right now?
Hello, everyone. Yeah, so I'm Michael. It's great to see you all. What was I doing when I was 15? I mean, I was in high school, I guess. You know, I think when I talk with my colleagues at Stanford, I think there are as many different paths to where we are at as there are faculty. So I would caution you not to overgeneralize based on what one person's experience was. I grew up in Southern California. I went to high school down there. I was definitely not at the high school that was the super smart magnet intellectual high school. My high school was known as being the athletic high school, but that was mostly, I think, because we weren't good at anything else. I just did a ton of different stuff. I was really involved in choir and musicals, so like singing, music, that kind of stuff. I was involved in student government. And then I was, taking just sort of like the honors classes of various sorts that my school was offering. But I think what I got from that is, ultimately, I think when I got to college, there were students who had deeper technical expertise than I had. But I think that the opportunity to sort of go broad, weave together sort of creative perspectives on things, what was actually most helpful, especially once I got into a PhD program and all of a sudden they stopped. There's like, wait, there are more classes I need to go learn from books. It's like I actually need to take creative leaps in the edge of what we know. And that was sort of continued through, at college, I didn't take a very traditional major. I was this very interdisciplinary major. And it made it harder at the beginning because I had fewer classes than my friends in sort of the standard coursework. but I was prepared to see connections that maybe others weren't, because I had taken lots of classes in like cognitive science and linguistics and philosophy as part of my major. So it was like I had to run faster, but a godfather, my colleague at Stanford, his name is Joan Osterhout. He likes to say that slope matters more than y-intercept. So like, even if I started a little further down, like, how quickly you're able to climb the hill is actually the thing that matters.
Thank you for that.
Yeah, so how would you describe the field of human-computer interaction, and what motivated you to pursue it?
Sure. So when I describe HCI, or human-computer interaction, to people, I usually start by saying that HCI is a field that's interested in how computing is empowering people to achieve their goals. So there are fields of computer science that are focused on things like making the computer faster, like if you're in systems, or smarter, like if you're in AI, or more secure if you're in privacy, security, those kinds of things. HCI is one that says, but none of this matters if we can't design technology that actually solves human problems. And so HCI research, which is what I spend most of my time doing, still does technical work. We're developing new systems, new algorithms, new designs, but we're usually starting from a picture of like, what's the world we're trying to create? How are people interacting with each other, or how are people interacting with technology? And then we work backwards and say, well, why don't we have that world yet? And to the extent that, sometimes there are social challenges there that we might work on, but, generally we're more focused on where are the technical limits. And then we say, can we address any of those technical limits with our tools as computer scientists? So HCI is a quite broad field. You have people like me working in what's called social computing. We're interested in helping people come together online, any technology that mediates human interaction. But then you also have people working on things like virtual reality, augmented reality, interactive devices, touch, haptics, conversational assistance, visualization, things like better tools of the sorts of like Photoshop and iMovie. It's really, there's a huge range of what people are working on. Anything that people are using computers to do, there are HCI people working on it. I think the other part of the question was, how did I get started into that field? It's a good question. I mean, I think this is another place where I would say you don't need to follow exactly my path. When I was starting, computer science was a very different field. It was more focused on the kinds of other sub areas that I was describing, things like AI and systems. It was those were sort of and computer science theory, like the mathematical foundations of computer science. And this HCI being an interdisciplinary field was played less of a central role. But in the intervening years, what's kind of happened is that everyone has realized that technology is sort of in the hands of people, and that so how we design that technology really matters. So for me, when I was growing up, the thing that I thought I wanted to do in high school was make video games. As you can tell, I kind of didn't end up in that path. I tried doing it for a summer and was like, this is a weird industry. Although I did really like how you had like artists and programmers working right next to each other. That was something I thought was really cool about the industry. But even stepping back from that, ultimately for me, it wasn't about video games per se. It was about, I found less art and beauty in exactly the method through which the computer worked, and more in what people were using it to do. I was more interested in using computation to create new kinds of experiences, to make people like be able to do things and feel ways that they couldn't have before, and less. And while I really enjoyed, the programming, the proofs, all that kind of stuff, it was not. It was more in service of that goal. I enjoyed it because it helped me create these new kinds of experiences, and that's part of what drove me toward. At the time, a computer science major really wasn't a great fit for me because it was very focused on those traditional areas. Nowadays, again, computer science has I think broadened, and I think it's more of a toss-up whether I would have ended up in this interdisciplinary program or computer science, just again because computer science is more broad now. But being able to draw on, how psychology, like how do people think about the world around them, and how does that translate into ways that we should be designing technology to amplify their thoughts, or more in the ways of the kind of work that I do now in terms of organizational behavior. How do groups of people, pull themselves together to get hard things done? Or sociology, how do societies coalesce, and how do some people get put down and others brought up through society, and what role is technology playing in that? All those kinds of things are, I think, influential in how we design the technology to either reinforce or dismantle some of those issues.
Thank you for that. Now, my next question to you would be, what advice would you have for young high school students who are interested in human-computer interaction?
That's a great question. So I don't know in your high schools, at least in ones that are in the US, I think there's, for people who are interested in computing, there's now a reasonable availability of, I guess, what I would call APCS, sort of like high school level, intro college computer science coursework. That was available when I was in high school, but I actually didn't take it because it conflicted with my choir, I think. I guess what I would say is more important than any sort of curricular goal would be to curate a sort of a twin competency in, formal sort of technical thinking, like the kinds of stuff you're probably already thinking about in terms of, you need to be able to think carefully and rigorously about how the world works, and that comes through a combination of math, science, computing, and so on. But then the other side of it is being able to do creative work in this space. So I was never much of a drawer, but if you're like into art, that's one venue some people come at this from. I was interested in stories and storytelling, and how that gets translated through these interactive games. I was doing musical theater, these kinds of things. Like, I think just, push yourself to think in multiple different ways, and to try and be the only good at one way of thinking. Because ultimately, when you reach the edge of your field and you're trying to really innovate and change it, you can't typically do that within established frames. You have to be drawing together new perspectives. There's a ton of evidence that this kind of drawing ideas from one field to influence another one is a really common approach to innovation. So I think that would be my encouragement, would be don't put all of your stats into just computing, because ultimately it's about what else you bring to computing that makes your contributions unique and ultimately influential.
Thank you so much for that. That's so cool. What got you interested in social computing and crowdsourcing? Could you give us examples of positive social change coming from social computing?
Yeah, so again, my story is never going to repeat itself, but when I was in graduate school, starting my PhD, I was basically the first cohort of people who were growing up with tools like Facebook. I grew up with things like Wikipedia, Facebook, and so on, where Facebook launched in, what was it, 2003, 2004, something like this. And it must have been before that, because I got it as, I think, a sophomore in college, back when it was only available to college students at a few schools. And I just really saw that there were a bunch of people in my field studying how these systems were influencing people, doing kind of the social science of these systems, but very few people were designing and building better ones. That was sort of being left to industry, and that seemed odd to me. Why would researchers who are supposed to be inventing the future of this field not be inventing the future of the field? So I guess I jumped into it on a hunch that I felt like there were things to do here. There were very few people in my field working in this space, and it was, so I was a little bit of a black sheep for a little while. No one was actively against me. It was just sort of uncommon. They're like, "Oh, okay, you're working in that space. Have fun." And when I discuss social computing, I teach this entire course on social computing now at Stanford, and I sort of bring it up by saying that, like, every social environment that we're in is designed, whether we think about it or not, right? How we interact with people on Zoom is clearly designed, because we are, like, there's software that's doing it, right? Like, whose screen is shown when, and what, like, who gets the power to mute who, and how does this influence how we interact with each other? What makes, like, a good interaction? What makes a bad one? But even a lack of a design is itself a design, right? Imagine that Zoom had not thought through these features and had just sort of implemented a thing. It was still making decisions that were influencing our world. I make this point by analogy to offline worlds, IRL. Like, if you're in a building, some architect has designed that building, and there's no way that a building cannot influence social interactions, right? Where the bathrooms are, where the entryway is, how people flow through the building, that has to exist in some form. So whether they want to or not, someone's making those decisions. And for me, it's important to recognize that those decisions get made and that we have to make them carefully. That's sort of a driving animus for me originally. And I would say clearly in the last 4 years or so, a lot more has been driven by how we have, what world we have wrought. That is to say that social computing technologies have clearly been used to produce negative outcomes in society, or to fuel negative outcomes in society. Here in America, we talk a lot about the roles of disinformation and so on, as it influenced our elections, but also harassment online, racism online. There's, all of these things are happening. Like, the internet, Clay Shirky in his book Here Comes Everybody, like, makes the point that the internet just makes it easier to organize, and it doesn't really care who's organizing. And so for a while, the thing that was mostly being helped was, we could bring together small interest groups like this group, say maybe that might be geographically distributed, that might otherwise be able to meet. That's really cool. We can do this. But it turns out that you can also allow the same technologies get used to also allow groups that you might not want to be organizing to come together on these platforms. And the very traditional computer science responses of, we should have very, like, decentralized efforts. Like, you have this decentralized version of Twitter called Mastodon, like, has a huge Nazi problem because they cannot control the negative behaviors that are happening on the platform. And so I think it's incumbent on us to be asking questions around, say, what does the future of governance look like online, right? Which is, I believe, a social computing problem. How should we be designing environments to have more positive interactions? How do we deal with people who are trolling, or who are harming each other, or bullying, right? How do we design environments that help empower the people who could help manage these issues to do so? it seems kind of incredible to me that, to make an analogy, imagine you built a big park, some park where people could play and interact and so on. And then on that park, a bunch of fights start breaking out, people start shooting each other, there's rallies for like really hateful causes. And then you, as the designer of the park, you're like, we're just a park designer, we're a technology platform. You know, sorry, right? It seems incredible to me that we would just sort of leave it out like that. And so I think we need to actually step forward, step up and say, how can we do better? What combination of people and technology can help us actually create, you know, a good park, right? One where we want to be. I don't think that it's impossible. I just think that the slavish adherence to like the magic of scale and like hands-offness is just not the way to go. I think we need to think a lot more about how we involve people in the governance of their own communities, and empower them to do so.
Thank you. That's a really good answer. So my next question to you would be, your research focuses on bringing people together to solve big problems. We need that more than ever right now. What role does technology have in responsibly bringing people together? Social media bubbles allow people to maintain their own sense of reality. How do we come together if we don't even share a common set of facts?
Two different questions that are both important. I view them sort of as different, as two sides of the same coin, right? You know, one way that I sometimes describe the first side, which is about like bringing people together with the sort of positive affect to it, is that my belief is that the next, you know, set of world wonders we create, the next major positive influences that we have, we're going to have to do as a group, right? It's sort of the end of the age of the individual contributor, where it's like some lone genius in their room who really changes the world. And I think we're currently in the age of like teams, of groups, of collectives working together. And so my contention, and you're welcome to disagree with this, but my belief right now is that if a group is to fail at their goal, it's becoming less and less likely that they fail because they didn't have the skills, and more likely that they failed because they weren't able to organize themselves, get along, and sort of pull it together. I can't tell you, how many times I've seen this happen, or even, been at fault in not helping it happen myself, where I try to learn and do better the next time. And so it seems to me, if you buy my argument that sort of the architecture of a space influences how we interact, then you have to then buy my argument that by designing the technology that helps us coordinate, we can help us have fewer collective failures and more collective successes. We can help ourselves diagnose, why are we not getting along as well as we ought to? What can we do about it? Who should be in this room right now? How can we make sure they're represented? How can we make sure their voices are being heard? How do we make decisions effectively? How do we execute on those decisions? Look, the internet is amazing right now at coming up with options. Twitter is a great place to sort of shoot out lots of different ideas, but the internet is a terrible place right now for making decisions and coming to consensus. And I think that, developing tools that support that kind of collective decision-making and execution, if paired with the kinds of affordances of the internet to help brainstorm ideas, could be incredibly powerful. Now, as you say, there's this other side that the decentralized nature of the internet and largely pseudonymous or anonymous sort of design of it gives, it was originally intentionally designed that way because the creators of the internet didn't trust centralized government. If you go and read the old like writings of these people, there's a famous article called basically A Declaration of the Independence of Cyberspace, where they basically say your governments are broken. We're going to create our own place online in the magic of the internet. And I think that works for a while. Sort of like when when you and your friends just start a club, you and your friends all get along well because you have like the same points of view. But then if this club or maybe this thing you're doing here becomes 1,000 people, you get multiple different points of view. You get more coordination costs. Like it's not sustainable. And so I think we're now fighting the negative outcomes of some of those early decisions, which gave, for example, really, really strong powers of speech to basically gave no ability to shut down hate speech and things like this because of the way the internet was architected. And so we either need to change parts of the architecture or we need to think about how civil society and government and policy play a role here. And like ultimately it's going to be some sort of combination of the two that has to succeed. But you know, we know from research that people are more willing to say harmful things online when their faces and identities are less attached to it, and when they can't see these like signals of emotions from other people. It has positive effects in that, you know, people are more willing to disclose private things about themselves, say things that like would help them, you know, work through really difficult circumstances. But I think largely right now the attention is focused on the fact that this, for a number of people, is like empowering hate groups and bullying and domestic abuse and things like this. You know, technology is used to reenact power structures that we've seen before. And you know, every technology is going to be co-opted in to the extent it can be to do those things. And I think the question is just how much power do we give them to do so?
That was
Thank
just fantastic. That was just incredible.
Yeah. That was amazing. Okay, so I think a question this data that obviously leads into is a common question asked today in the field of HCI is whether there is need for an ethical framework in the field of digital design. We are all extremely aware of the discussions around ethics in HCI. Social media companies have faced a lot of flack for exploiting our worst tendencies. How do we, as future HCI scientists, commit to a more ethical design framework?
Right. Well, you know, HCI has a lot of tools for doing this, and I think they had been somewhat underutilized, I guess is a way of putting it, before now. So if you Google terms like participatory design or value-based design, these are methods that are, or excuse me, value-centered design, that are designed to counter some of these issues. So for example, participatory design, okay, traditional design, let's start with how does it usually work? Like in the course, in like intro to HCI, when I teach intro to HCI, how has it historically been taught? So the idea is that the designer goes out and interviews what are known as stakeholders. So these are different groups who will be influenced by a system. So traditionally, this would just be like, who are the users of the system? If I'm going to design, I don't know, what's a really boring thing? A calendar app for the iPhone. You know, I will go interview a bunch of people about how they manage their calendars online and offline. I'll look at what they do today to manage using apps. I try to understand what their needs are. Things like, you know, they need to be aware of upcoming events. They need to make sure that they have confidence that they understand that they're not missing something, etc. And then I, as the designer, go off and try to come up with a solution to that. Something like participatory design says, wait, why aren't the groups impacted by this more a part of the process throughout? So that process could arguably make sense if there's sort of like a single user and you can build empathy with that kind of a user point of view. And that's the kind of thing that I think has succeeded very well at companies like Google, Microsoft, and Apple. Just sort of like, this is a tool, and so we need to sort of understand the variety of perspectives on this tool. But when you have things like Facebook, Wikipedia, Twitter, Instagram, Snapchat, TikTok, WeChat, etc., what's actually happening is you have many different groups of people who have different interests and goals all intersecting on the platform. And so if you just go out and talk to people, you're probably mostly talking to the people who are most heavily represented, and you're like missing voices. So participatory design says, bring these people to the table, get them involved in the process where you're doing the need finding, get them involved in the part of the process where you're actually designing the solutions, giving feedback, etc. And you will hear voices that you wouldn't have otherwise heard. So that's one angle, is that I don't think that's an ethics angle, in that like ethics are largely concerned with let's call them principles of what is a good versus a bad design, say. But that's not a disparagement. It's simply saying, I think a lot of the ethical issues would not have come up had, say, let's just take the case of harassment of women and on Twitter, if more women had been at the table in the design of these features, right? The other angle is just explicitly about ethics. And I'll tie together two things. There's ethics and societal impact. So ethics would be a question of, is this an ethical decision? But something can be ethical but still have unintended societal consequences, right? Or something can have no societal consequences but still be unethical. So I want to sort of tie those two things together, or say that they should go together. And I can tell you one thing we're working on at Stanford. No suggestions that it will necessarily take over the world, but I hope it might. And that's to involve more of a societal and ethics review as part of any product design or research process. So we've partnered with Stanford's, this is not public, so please don't tweet or say anything about this right now, but just sort of to get a sense of something that's happening. We're partnering with Stanford's avoiding some of these issues.
Thank you. That was an amazing answer. I read some of your research papers and they were really great. And so in relation to them, in your research paper, you talked about a system called Hive that you created, which intermixes people instead of ideas. Could you elaborate on how this system works and why the system is more beneficial when it comes to exchanging ideas and information?
Yeah, so to give a little context for everyone, this is a project that was focused on how we can help communities come together to solve problems. And there's a bit of human psychology, which is that we kind of, there's a term called design fixation. Fixation means that we sort of like fall in love with a thing. So that if we're brainstorming ideas for a solution to a problem, we latch onto one that we like and we just sort of never let go. And unfortunately, this ends up being bad for us because it means that we tend to fixate on ones that may not be the best idea, or we ignore other seeds of ideas that we really should have pursued. This is well known in the design literature. And so what a designer is often actually being trained to do when you go to training for like being a human-centered designer is you're being trained to kind of let go of those ideas for a little bit, explore the space, and then make a more considered judgment. So we can't train everyone as designers, so what do? It turns out, like, let's say we all had a brainstorm as a group, all 20 of us, or however many there are, 26, okay. Yeah, all 26 of us, we're gonna have a brainstorm about like, what's a better version of a social network look like? Say, we were gonna just like try to brainstorm, how do we fix some of these issues? We'd all get into, we'd brainstorm individually, then we come into groups and we'd brainstorm in groups. And imagine I were to then, the group were to leave behind its best idea and pitch it to another group, and everyone's getting pitched someone else's idea. And think about it. How many of these groups do you think are going to let go of their idea and go start working with another group's idea? It would be nice if like the best idea, like there was an economy of good ideas and everyone was like that one, and we're all going to go work on it. In reality, what happens is everyone just sort of, they're like, no, mine's better. So it turns out that there's one way to combat this, which is to sort of intermingle the people, so that if people representing that idea are now on the team, it actually tends to stick a bit more. So this becomes an interesting social design problem where we want to sort of intermix the people representing different ideas. But if you just sort of randomize everyone in the group, then you have another problem where no one knows each other and they don't trust each other. So we have actually what ends up being a kind of joint optimization where we're trying to get new ideas coming around, but also keeping groups together when possible to try and maximize familiarity and trust. So in the Hive project, what Nilüfer Salehi, my PhD student, who's now faculty at UC Berkeley, what she was doing was developing an optimization algorithm called network rotation that tried to balance these two forces. So the idea would be that you have this group come together and they'd be formed into small brainstorming groups. And over time, this algorithm is deciding, okay, now we're going to sort of rotate who's on what team, but I'm going to do it in such a way that's intelligent, that I'm going to try to balance such that people, parts of the team stay together, but then we're bringing someone onto the team who's really far away in the collaboration network and brings in new perspectives. And we're going to do this, imagine we did this every, day or two, it would be diffusing these ideas through the space. That was the idea behind the project. And, there's some fun algorithms of like behind this, there's, it's stochastic and, randomized and cool stuff because it's actually like, I think it's NP hard. But that was the major idea, was to be able to find ways to pull together the right people into the right groups and evolve those groups over time to get the ideas flowing.
Wow, that was an amazing answer. So On the lines of your research papers, you recently made PolicyKit, a software and infrastructure to help move the world of governance in online communities from permission to procedure-based ideals. Could you elaborate on what exactly this infrastructure is and why you believe it is necessary?
Sure. So I don't know if you've ever stopped to think about it, but most software for sort of online gathering and interaction is basically dictatorial. Like the model that it takes is one of like admins and moderators who have complete control. And that's one possible governance structure, but it's only one. And there's a wide variety of other kinds of governance that you might want to actually pursue, especially including ones that are like more participatory. Like, how could Facebook operate democratically? How could, you know, this subreddit that you like participating in have more participation, not just from the mods, but from the people who are in it? But that's just not how the software is built. So PolicyKit is software infrastructure that integrates with a lot of online community software, including Reddit, Slack, I think Discord at this point, that allows, think of it as a programming language built on type of Python that allows you to author governance for your community. And the basic idea is that instead of permissions-based approaches, which basically says, you know, mods can do this, regular users cannot, it's procedure-based, which is much more like if someone wants to do X, then the following process is followed. There's a post made to this channel, and then a vote is taken, and then if the vote passes with a 2/3 majority, then it goes to this, your elected president who can veto it for a week. Whatever governance pattern that you imagine, you can program through PolicyKit. And the vision is that we could use this to bring more, I guess, ideally democratic governance. Probably, honestly, we can't do it initially to the big companies like Facebook, but at least to within groups within that could then start to put pressure on the larger organizations to enable similar things.
Thank you. That was a good answer. So my next question for you would be, in your research paper, Iris, you have built a conversational agent which completes complex scientific tasks for its users. As I am also building a conversational chatbot, what were some of the difficulties you faced while building Iris, and how did you overcome them?
And Michael, if I could stop you right there, I would actually love to show you Anushka's chatbot. So you also have a sense of what she's been doing, and I think that would just be quite lovely. I'll just share my screen. Give me a second. Can you see my screen?
Yes.
Perfect. Yes, Anushka, go on.
So here's the chatbot. Currently, we've designed it as a website, so it's easily accessible by anyone who wants to use it. So how it works is, so you enter in the chat area your interests or your favorite subjects. So here, Manu's entering, I've always loved physics. And so the chatbot returns to you. We've made interest pages with external resources related to that subject, as well as videos. So that pertains to what the user might be interested in and may expand his knowledge on it. And we've also used AI to figure out the intention. So let's say the user says, I love painting, and not directly says, I love art. So it figures out that the user may be interested in art and does the same thing for that. And another feature that we have is the chatbot will ask for the user's zip code, so they can find relevant interests and jobs that they can find in their area. And we will also be converting this into Indian languages, so it will be easier for them to access. And this is an example of one of the interest pages.
Nice. Thank you for sharing that with me. I definitely don't think I could have implemented that in high school. That's cool. Yeah, so I guess, we've been doing a fair amount of work in conversational agents recently. You asked about the Iris paper in particular. I'm going to generalize a little bit so that it's not specific to that paper, but to tell you some of the things that I'm thinking about in this space. And just to sort of set expectations, I don't know the answer to this, and so I'm not suggesting that you necessarily would implement a chatbot that can solve this, but I can tell you it's a kind of thing that we're thinking about. So chatbots are a really fascinating interaction paradigm for a number of reasons, but one of the ones that really gets stuck in my craw quite a bit is this, how open-ended they are. So language is a really, really fascinating mechanism for communication when you think about it. For a long time, computers were basically, seen as tools, like kind of like a really powerful calculator or hammer, where like, I'm just trying to tell it to do X, and then it does the X, right? That's why we have things like buttons and drop downs and menus and shortcuts and terminals. And computers don't like ambiguity. You've probably noticed this, that they'll crash if you're not very, very specific in writing your program. And so language is kind of nuts because language is ambiguous, right? We're trying to take something that's inherently ambiguous and we're trying to translate that into something that's extremely precise for a computer to be able to operate on. And that translation is both challenging and I think raises to me some very fundamental limitations as to how computers work right now. So the original goal of the Iris project was to say, how can we enable more complex work? And we took this notion of like helping people do basic data science tasks as a goal, as a representative of that. But really, I think, if you imagine trying to do that with like Alexa or Google Assistant or Cortana or whatever there is these days, Siri, it would just fail. And the reason it would fail is that the space of possible commands I'd give is much larger than the space of commands that these assistants know how to parse. And so if I'm like, Alexa, turn on the lights, and someone has programmed that exact phrase into it or a regular expression that sort of roughly represents that, then great. But if I'm like, Alexa, it's dark in here, or Alexa, I can't see, which resolve to the same implication, Alexa's like, I can Google that for you, but it makes no sense to them. And so with the Iris project, okay, so the goal was just to be able to say, how can we enable that kind of ambiguity in large command space, given, that there's a finite, that you have like, what did you say, 2.5 more years in high school, right? And you want to finish before the end of that or something like that. And you can't just program every possible command. So the idea that project was particularly pursuing was creating a sort of composable grammar, like that I can create little simple elements and then create ways to combine those simple elements that would enable a very, very large space of possible commands. Did we ultimately succeed at that? I think, partially there was some really good stuff that came out of it. But I don't think we're fully there yet. But that for me is what's really fascinating about the opportunities and the challenges with conversational interactions, is just that there's, human interaction works very effectively to resolve ambiguity in many, but not all cases. But we don't know how to do that with a conversational agent. And developing techniques that would allow that, I think, would empower all sorts of different agents, including yours and others, to succeed. Another crazy thing we found. Yeah, go ahead, please.
But doesn't that mean that you have to solve the exponential explosion of relationships that are immanent in language and which computing hasn't solved yet?
Yes, exactly. And that's why it's hard. But that's also why it's fun. So by creating, so with Iris, the answer is that if you have an exponential problem, you have to solve it with an exponential solution. So with Iris, that particular project, the idea was to create a grammar of things that can compose. And because it can compose, you can create an exponential different number of compositions that then allow essentially all these pieces like Legos to be built up to create any arbitrarily complex thing. That was the answer there. Is that the right answer? I don't know. You know, Anusha, it looks like you had another solution, which was to use information retrieval kinds of techniques like TF-IDF and cosine distances and lookups to try and resolve a huge search space onto the nearest thing you know about, which is another possible answer. I guess what another way of answering that question is that while the space of possible language actions or behaviors is quite large, the number of actual commands or things that might be done is substantially smaller. And so really, if you take advantage of that, you can succeed, maybe, right? We haven't seen anyone really succeed at this, but I think that there's more of a chance. We built a conversational agent. This isn't published yet, but we have some work where we built a conversational agent to interact with people about their Instagram photos, basically. And it's a reinforcement learning agent, which means that you have this, to get sort of weirdly technical just for a moment, your action space, the set of possible behaviors is exponential. It's like, how many different words are there in the English language to the power of how long is your sentence? And with any kind of non-trivial sentence length, the size of that space is larger than the number of atoms there are in the universe. Which
there is a
go ahead.
There is a light at the end of the tunnel, because in all languages, because the human brain output infinite number of languages, so it's some mechanistic abstract thing. What we found is that between 6 and 7 connections give you a unique record with an infinite.
What do you mean by a
number.
connection?
I mean, think of it as a matrix. You have as one guy said, you have 100 order matrix. You have, as you said, more molecules than in the universe. But if you can handle, that's the exponential problem. If you can handle 6 to 7 connections, you actually get a unique record. And that's how you get meaning and context. And that meaning and context exists for any language. So it's actually a mechanical process. In a sense, the way we approach it is the brain is very complex. The output of the brain is language. So the easy test is that if you ask a question, does the answer make any sense? And if you stick to that, you eventually hit upon how you get meaning, and you get a meaningful answer which overcomes ambiguity. We tried it as
sure.
very,
you're sort of pitching a Turing test, right? Which is, if
the Turing test again is limited by it's a magical trick, which eventually now is considered as a trick, in the sense that if you can trick the person who's asking the question, it's not really overcoming ambiguity. It's really a game.
I'm not sure whether you're making a claim that is sort of like a Chomsky deep grammar kind of argument, that there's like inborn in our brains due to the structure of the brain that there's only a small number of possible like linguistic forms, and so all languages derive from that, and if you can just deconvolve that back to the original, deep grammar.
No, that's what I'm saying. It's an exponential problem. The key is, if you want to hit the bullseye, is to understand how to. So, a simple problem is this: the same thing that you're saying. If you have one single file, which at the end, when it becomes very big, becomes exponential, how do you create in that one single file when it becomes exponential? This is the dilemma for information technology. How do you keep the line straight? What people tend to do with large amounts of data is that they add more processing power and create memory, etc., etc. But actually, there is a technical solution. The technical solution is, instead, at the point where it's about to go exponential, how do you manage to keep that as a straight line? And it is possible.
Sure. Yeah, I don't think well, I would use different terms than you. I think that I'm not disagreeing at the fundamental level. I mean, one way to view it would be.
I haven't been to Stanford.
I mean, do you need to?
No, why not? To use certain terms, you have to, yeah.
Well, so I guess one way to view this is, okay, there's imagine you were trying to compress all the language in any language, let's just pick one language, pick your favorite, into some representation. You could run PCA or build a deep net or anything to arbitrarily basically create orthogonal vectors that are here's sort of the major axes of differentiation and meaning within this language. And that would capture, based on a bunch of different estimates, you're probably about 80% of the variation. And I think we can and I'm just going here off 80-20 rules kinds of things. And so the question is, what do you want to do about the remaining 20%? It gets much messier. If you want to capture, so I think there are two sides of this coin. One is to say, oh, well, we can actually do really well by having the right model at a fairly low dimensionality. I think in that sense, I'm agreeing with you that most things people are saying fall into a much smaller subspace or manifold. And
Gregory Bateson talks about this in terms of it being innate. For example, you don't have to declare a synonym if the two words exist on the same surface. Then the synonym becomes innate, and you have to use less processing power and less, it reduces the number of combinatorial.
Sure. Yeah, I think
problem.
I think that, I guess my feeling is that, again, most stuff falls into that. And then there's a huge number of things that cannot be captured that way, because if they could, then you would need much less processing power, much less language. There's a lot of results that show that language is actually about as efficient as it could be given what we're trying to say. And so, oh yeah, go ahead.
Yeah, I really appreciate that, Michael. I know I really want to honor your time. It is 9:34, Indian time. I guess that's 9:04 your time. We do have a final question from Arav that I want to make sure that we get to, because I know he's really excited for it. And thank you for your questions, Vidar sir. If you can always reach out to Professor Bernstein directly. Thank you so much. I really do appreciate it. Arav, over to you, please.
Okay, yeah. So how do you think teenagers can harness the power of HCI in crowdsourcing to help build high impact social projects to help their community? What are the different little thoughts you have that you think teenagers can pull off?
And to add to that, Michael, every single person in this call is really excited by your research and really wants to build HCI tech and help people. Are there avenues you see that they could directly work on stuff like that?
Absolutely. Well, I guess I would start by saying that I think you all have points of view onto the problems that need to be solved that are probably more in tune than mine, in some ways. And so I would encourage you to reflect on the communities around you. But I don't think you need to wait to do so. When I teach my social computing class, the slides for all this are online if you want to like ever go dig into it. I have an entire lecture on prototyping and what I call social bricolage. And that's just a fancy term for saying duct taping stuff together. And what it means is that if you have a picture for how a social computing system could work or ought to work, there's usually a bunch of existing systems out there that you could sort of kludge or duct tape together in an awkward way to try it out. Programmers all too often have this goal of like programming too quickly. You have an idea and you immediately program it. But one of the main ideas from HCI is that you never know up front whether it's actually going to succeed. So you want to not program until you know if it's going to succeed. So if you're going to if you have an idea, the right thing to do is to just kludge together, to sort of pull together existing tech and maybe add some like rules that we all agree to on top of it to see if it does the kind of thing you want to do. Okay, you want to build a crowdsourcing system? Maybe a Google spreadsheet is like the first thing you need, and just try it on that first, right? But through some combination of, SMS, internet technologies, the, wikis, email, text, like images, all this kind of stuff that's out there, you can prototype basically nearly any social system to a first approximation. And then if it's going really well, you can program it. You can really make a thing and launch it. So, Anusha, to take the example of your conversational agent, one thing a person could do is literally just, you just launch it, right? And you do it by like text messaging people or using WhatsApp or whatever. And you're just writing the responses for now, right? But if it seems to be a good idea and people are really finding value from it and it's working well, and you've learned things about how they like to interact with, Anusha bot, then you can start to program that. So I very often encourage my students to start with these lo-fi versions of their ideas. And that's something that I think any teenager can do, because it's the idea that's hard to come up with. And once you have a good idea, then we can always talk about how to hack it together and program it and make it, work on the cloud and all that kind of stuff. But getting the feedback on whether the idea works, you don't need to have a PhD in CS to do.
I love that. Thank you so much for your time. Anushka, any final things that you want to say? Arav, any final things you want to say?
I think so much.
Yeah, my pleasure. Thanks for joining.
Thank you so much, Professor Bernstein. I know you're so busy, and it really, really means the world to us that you could come today. And I hope that was a very, very useful session. And I think, the core messages that you left us with about really building technology so people can come together and not thinking of it as in terms of the park, and anyone can just come in and do anything, but really designing it in a way that, people do beautiful things with it. And if there's anything, we've all seen what's happening around the world. I think Professor Bernstein's message to build meaningful, beautiful technology that is well designed and thoughtful is the big hope that we have. Thank you so much, Michael. It means the world to me. I really appreciate it. Thank you.
All right.
Thank you so much.
My pleasure.
Thank you.
Good to see you all. Have a great
you.
evening. I guess your time.
Thank you.